Okay, so we're going to do question 9.27. So this is just the same utility functions as in question 9.24, but it's asking you to find the Hicksian demands, which is the consumption bundle that is minimizing the cost in order to attain a certain level of utility. Okay, so in this case, we want a utility level of U0. And we try to find a consumption bundle that is that is minimizing the cost of consumption, which is the acquisition cost. Okay, so again, A and B are special cases where we have perfect substitutes and perfect complements. Now again, these two cases are going to be easiest way to find the optimal bundle in this case is to draw the graph, just like what we did before, to find the Marshallian demands. So it's very similar. We just have to look at the graph, and from there we should be able to see straight away. Okay, so first I'll start out by writing our problem is basically try to minimize with finding. We have to find x and y to minimize the cost of px times x plus py times y. Okay, so this is the acquisition cost or the expenditure on the bundle x and y. So given that px equal to 5, so that is 5x, and py equal to 5, so that is 5y. Okay, and subject to a constraint that we have to reach a minimum acceptable utility level of U0. Okay, subject to the fact that the utility has to be equal to U0. Okay, so we start with part A, where the utility is taking the form of 3x plus 2y. Okay, so our constraint in this case, we want this to be equal to U0. Okay, so x and y, it doesn't matter what you choose, it has to satisfy this equation. So 3x plus 2y, it has to be equal to U0. All right, so this is our utility constraint. So first of all, we are going to draw our constraint on a diagram, and after that, we are going to draw a field of the acquisition cost curve, and try to find the lowest one, which is the minimum one. Okay, so I will have a diagram. Okay, so again, I will still have y on a vertical, I have x on a horizontal, I have 0 over here. Now, so first of all, I would like to draw this line over here on the diagram. Okay, so 3x plus 2y equals U0. So if you rearrange this, you get 2y equal U0. Remember, we are treating U0 as a constant, which is a certain level of utility that we want to achieve. Okay, minus 3x. So therefore, y is going to be equal to U0 divided by 2 minus 3 onto x. Okay, so negative 3 on 2 is the slope, and U0 on 2 is the vertical intercept. Okay, so therefore I got V0, sorry, not V, U0 on 2, which is the vertical intercept over here. And the slope is negative 3 on 2, which is bigger than 1. So I'm going to have a straight line going all the way like this. Okay, so this is my utility constraint. U0. Okay, so every point x and y on this line is going to have a utility level of U0, which is what we want. Okay, so which bundle should we choose? Now we try to choose a bundle that is minimizing our cost, which is minimizing the expenditure function over here. So what we want to do is we want to draw the expenditure curves, okay, on a diagram and see which one is going to be corresponding to the bundle. So which bundle is going to be corresponding to the lowest line, okay? So this minimum expenditure is 5x plus 5y. So therefore, Okay, so therefore when you draw it on the diagram, it's going to have, so as you can see, if you rearrange it, okay, so what I say is, okay, so if I make, so I call this is the acquisition cost, which is C, okay? So if you rearrange it, then it's like 5y equals C minus 5x. And so therefore y equals C on 5 minus x, okay? So corresponding to a different level of C, we are going to have a different line, okay? The higher the value of C, the higher the line is, and the slope is -1. So if you compare the slope of, so this is the slope of the UTD of the indifferent curve, and this is the slope of the acquisition cost. Then the indifferent curve over here, okay, the UTD curve over here is basically steeper because the absolute value is bigger than this slope, which is -1. So therefore, when you draw the acquisition cost line, it is going to be flatter, okay, then the UTD line. So I'm going to draw a pure flatter line, just like this, okay. Okay, so I just say I got a few of those, and all of these having a slope of -1, okay. All right, so I say this is the cos C1, this is the cos C2, this is the cos C3, okay. The higher the line, the higher the cos, okay, and the slope of this one is -1, okay, while the slope of the UTD curve is -3 on 2, so therefore it's steeper. All right, so which point on the black line that we are going to choose in order to be on the minimum expenditure line? So the lower the cost, the better, okay, because we try to minimize the cost. So we try to pick a bundle that is on the lowest cost curve, and that is the bundle over here, okay, which is on the black line and corresponding to C1, which is the lowest cost possible, okay. So in this case, the optimal bundle is where the consumer is spending all of the money on X and none on Y. Okay, so Y equal to 0. Okay, so if Y equal to 0, then if you substitute that back into our constraint over here, then you find that 3x plus 2y. Okay, so outside this is the constraint star. So 3x plus 2y and y equal to 0 is going to be equal to u0. So therefore, x equals u0 divided by 3. Okay, so I do not know the value of u0, but I know that it's just basically a level of utility that the consumer would like to achieve. And so this is the optimal bundle, x equal to u0 on 3 and y equal to 0. Okay, so this is the Hicksian demand for y and x. All right, so very similar for the next case, where I have a perfect complement, right? So the utility is taking a form of the minimum between 2x and 3y. Okay, so now we will just have to draw the utility level curve u0, okay, and try to find a point on that curve, the consumption bundle on that curve that is going to be corresponding to the lowest cost. Okay. All right, so I would just have a normal diagram over here, where again I put y on the vertical and I put x on a horizontal, and this is 0. Okay. So in order to draw an indifferent curve or the UT level curve for this, we know that it is going to be an L-shaped curve. Okay. So just like what I remember I did in the previous video about a perfect complement case. Okay. So in order to draw the indifferent curve for that, you just have to find a few bundles that are going to be having the same utility level U0. Okay, so the first bundle so say if we had 2x smaller than 3y, okay, then the minimum between 2x and 3y is going to be equal to 2x U0, okay, and the minimum between 2x and 3y is going to be 2x, and that equal to U0. Okay, so therefore x is going to be equal to U0 divided by 2. Okay, so the first consumption bundle where x equal to U0 on 2 and y equal to 0 is going to be the first consumption bundle that is going, and for any y is bigger than that. Okay, so look at the condition over here, then I know that y has to be bigger than 2 on 3x, okay, and x equal to U0 on 2, so 2 on 3 times U0 on 2, and that is going to be U0 on 3. Okay, so any x equal to U0 on 2 and y is bigger than U0 on 3, then it is going to be lying on the indifferent curve with a UT level of U0. Okay. So for example, I would say I make U0 on 2 over here, and I say I make U0 on 3 over here. Okay, so so when x equal to U0 on 2 and any y that is bigger than U0 on 3, those bundles are going to be having a utility of U0. Okay, and so therefore they are going to be on the indifferent curve. So therefore it's going to be anything with x equal to U0 on 2 and y bigger than U0 on 3. So that is going to be that part of the line. Okay. So the second case is if 2x is bigger than 3y. Okay. Which is basically means x is bigger than 3 on 2y. Okay, then in this case, the minimum between 2x and 3y is going to be equal to 3y, and we want that to be equal to U0. Okay, so therefore y is going to be equal to U0 on 3, and we know that x has to be bigger than 3 on 2 times y, which is U0 on 3, so therefore it's going to be equal to U0 on 2. So any bundles that is having y equal U0 on 3 and x bigger than U0 on 2 are going to be staying on the same level of utility U0 on the indifferent curve with a utility level of U0. Okay, so therefore we know that it is going to be the horizontal line at the level of U0 on 3. Okay, so any point on this horizontal part is having y equal U0 on 3 and x bigger than U0 on 2. Okay. All right, and the last case, which is when x equal to 3y. And this is basically the easy case where okay, so if 2x equal to 3y, then the minimum between 2x and 3y will just be equal to either 2x or 3y. Okay, so the minimum between 2x and 3y equal to U0, that is corresponding to 2x equal to 3y equal U0. Okay, and so therefore x equal to U0 on 2 and y equal to U0 on 3. Okay, so so this bundle is also having a utility level of U0, and that is basically the vertex or the kin point over here. Okay, where x equal to U0 on 2 and y equal to U0 on 3. Okay, so this is our indifferent curve or the utility level curve corresponding to a utility level of U0. So that is how you draw the indifferent curve, okay, for this perfect complement sort of utility function. And so now we want to find a bundle on this indifferent curve, okay, or on this UT level curve that is corresponding to the lowest cost. Okay. So again, we just have to draw a few cost lines, just like what we did in the previous part with a slope of -1. And we try to pick the point on the black curve, on the UT level U0 curve that is corresponding to the lowest cost curve. Okay, so slope of -1. So this is UT level U0. So this is U0 on 2, and this is U0 on 2, so that will make my blue line having a slope of -1. Okay. Okay, so I'm just going to draw a few line, and remember they have to be parallel to each other. Okay. All right, so this is my cos C1, this is my cos C2, this is my cos C3. So I want to find the point on the UT level U0 curve that is corresponding to the lowest cost. Okay. Now, if I pick this point on the black curve corresponding to C3, I pick this point corresponding to C3. Now, if I pick this point corresponding to a cost curve going through that point. So as you can see, this point over here is going to be the point that is corresponding to the lowest cost, which is C2, and you would not be able to find any lower cost than that. Okay, so therefore the optimal bundle in this case is just the vertex point over here. Okay, where x is equal to U0 on 2 and y equal to U0 on 3. Okay, so therefore the Hicksian demand, which is the optimal bundle, is U0 on 2 and YH equal U0 on 3, okay, which is the bundle over here. All right, so that is the special case 2. And now we're just going to the very normal Coptolas utility function, which is a very normal case, all right? So for the rest of the exercises, for the rest of the cases, you should be able to apply the optimal conditions where the marginal rate of substitution has to be equal to the slope of the budget constraint. The slope of the UT level curve, it has to be, again, it has to be equal to the slope of the acquisition costs, I would say in this case. Okay, so okay, let's just get on with that. So I got a UT level x, y equal to x to the power half, y to the power half. Okay, and I want this to be equal to U0. Okay, now again, the optimal condition is still the tangency conditions where the marginal rate of substitution, okay, which is the slope of the utility level curve, it just has to be equal to the slope of the acquisition cost, or the price ratio, the negative of the price ratio px and py. Okay, so in this case, marginal rate substitution is just the ratio of marginal UT of x and marginal UT of y with a negative sign in front of it equal to negative px on py. Okay, now given the utility function over here, again, it should be straightforward to find marginal UT of x and marginal UT of y. Now this is exactly the same function as what we did in the previous exercise, so I would not go through step by step, so I'm going to do it quickly. So marginal UT of x is just going to be equal to 0.5 x negative 0.5 y 0.5, okay? And marginal UT of y would just be equal to okay, 0.5 x 0.5, y negative 0.5. Okay, and that has to be equal to px on py, which is 5 on 5. All right, so I'll cancel the negative sign, so I won't have to carry it on. 0.5 cancel 0.5 and simplify, I get y on x. And that just has to be equal to 1, so therefore y is going to be equal to x. Okay, so this is the optimal condition. And knowing this, if I substitute this into my constraint, which is the utility constraint, remember, in this case, we try to find, we try to achieve a certain level of utility. So we have a utility constraint, u equal to u0. Okay, so what I got is x to the power half and y to the power half, and y is just equal to x, which is the star condition over here. So times x to the power half, and it has to be equal to u0. So x half times x half will give you x, and so therefore x is going to be equal to u0 and also equal to y. Okay, so therefore this is my Hicksian demand, which is going to be the bundles that achieving a utility of u0 and corresponding to the lowest cost. Okay, so x hash equal to u0 and y hash also equal to u0. Okay, so similar to the previous exercise, I'm not going to go through all of the utility functions, but the rest of them you are just going to use the tangency condition over here. And the only thing you have to do is to find a marginal utility for each of the utility function. And after that, just substitute the optimal condition back into the utility constraint over here. Okay, and so from there you should be able to find the Hicksian demand for x and y.